Hi, as some of you might know that in the past months I have been vibe coding my own product, my own functional MVP that I've actually put into the hands of users. And this product happened to be an AI native RAG product, so it had a RAG pipeline at the heart of it. And I wanted to talk a bit about how I built a functional MVP that isn't total AI slop as a non-technical PM. When I say non-technical, I mean that here goes the elephant in the room, I cannot judge whether the code is good. I do understand a little bit about architecture, about databases, about technical trade-offs that you need to make, but I cannot actually read the code and check, is this good? So I will start with my first question, should I be vibe coding at all? I've seen this meme around, and I was wondering, do I have shiny new object syndrome, right? Like, am I getting distracted from doing proper, good product discovery work? Because I'm so excited that I can build now, and am I like losing sight of what really matters? And there is a real risk of doing this. But I think that delivery feeds into discovery, and discovery feeds into delivery, if we meet some criteria. Number one, I think there's an important prerequisite. You need to have at least a directional read on what might likely be an important opportunity. So a customer wish or a customer desire or a customer pain point, something that your idea can respond to. And in my case, I had done interviews, I had done landing page tests, I had done one-on-one prototype tests, but not as many as I usually would have before building an MVP. I was comfortable with building the MVP a lot sooner than I usually would have because the unit economics have changed so much thanks to vibe coding. But I did have at least a directional read on what might matter. I had clarity on which riskiest assumptions the MVP tests. The first one being, and this was very important, I can get my ICP, in my case these were solar company managers and leaders, I can get them on the phone if I offer value first. So this goes back to why I built my MVP sooner than I usually would have. I had been trying somehow a little bit successfully, but not successfully enough, to get my ICP to talk to me for interviews, and I had very poor cold outreach ratios, which makes total sense because why on earth would they want to talk to me? No degree of fake personalization is going to get that. That makes sense. They're busy people. So I needed to give them something first. And I figured, why not try with this thing that I have a hunch they might care about. So it's a bit of spaghetti against the wall, but not too bad, I think. And second assumption is my ICP is interested enough in the value prop to try it at least once, and I can build an MVP that delivers good enough output within 2 months. And I also set some success metrics up front. So basically, if we vibe code an MVP and run it like a proper MVP test, and the timing is right, I do believe that vibe coding helps, aids discovery, and is not a distraction. And of course, for me, a big bonus is that I had the luxury and the luck of already working with some AI native products, but by building my own AI native product by myself from scratch and making every single decision, I learned loads, right? So it's like an excellent course. So here's the big problem with non-technical people like myself vibe coding stuff and putting it into the world, is that people are overwhelmed. There is too much market noise as it is, even if you count actually good tools, right? But if we start putting out tools that are buggy and broken and AI slop and insecure, that erodes user trust and it kills early adopter appetite, and it basically ruins the game for everybody else. And I think that's a real serious problem that we need to be aware of. But I think we can mitigate that a bit by how we build, how we test and evaluate, and how we communicate. So those are kind of the 3 pillars that I went with. And so here is Vera TechAssist. This is the MVP that I built. That's my case study. As mentioned, it's for solar companies, so solar installation, solar maintenance, from like 20 to 200, so relatively smaller companies. And it's this free beta tool that helps them get answers to technical questions faster. So technicians are on the job site, they have to troubleshoot an asset, or they have to answer some technical question. This is really complicated at the moment. Usually they just call the back office and just say, hey, I need some help, and maybe the back office can help. Or the back office then needs to look for the right OEM manual and look through it and figure out what the technician should do. Or the technician just walks around the job site and sees if there's another technician there that could help. So it's very hodgepodge. It's not great. So I figured this is a perfect use case for AI. So the product is very simple. There's like a document library where the back office staff can just upload 100 manuals, like a bunch of manuals, and maybe internal service reports, any documents that they trust in PDF format. Then I have some parsing service I'm calling Microsoft Azure Document Intelligence to turn that PDF content into something that an LLM can work with, which is JSON in this case. I cut that into little chunks. I have a chunking service for that. I call Voyage AI to embed that. That means that I take this text and turn it into numerical values that help the LLM understand the meaning, like really like the semantic meaning of what is in the text. And I store that in Pinecone, the chunks in Pinecone, and I also store stuff in PostgreSQL. And then on the other hand, I have a chat. This can be used much later, at any time, by a technician or someone in the back office where they have to describe an asset. So they say, hey, I'm installing this panel. And then I have a hybrid search that uses both the PostgreSQL and Pinecone to find the right document. And it then says, hey, here's force ranked the most likely documents that you need. Then the user selects one, and then they can answer a technical question. I call Claude 4.5, or my product calls Claude 4.5, to answer that question. And what's very cool, I think, is that in the chat, there's a button that says see the original text. So if they click it, it opens and it renders within the browser the original PDF, so they can cross-check. And they also have access to all of the tables and graphics and images. So that's basically what it is. It's free, the value I discussed. The stack, I used Replit. I just really like Replit. I started on Replit. I'm now using Agent 3, which is like super cool. I use it on high autonomy. I think it works very well. I've used V0 as well for websites. I haven't even tried Lovable yet. I will. It's just that Replit just works very well for me. And what did it cost me? I guess it's interesting. I spent about a month and a half at about 10 hours a week. So I didn't work on it full time. And in total, I spent a little shy of $500. Which is insanely cheap if you think about the fact that it's like a fully functional mini product, actually, that usually I would have spent 50K at least to have an agency build this. Plus, I learned so much along the way, right? So I find the cost extremely low. Now let's dive in. First, mitigating the risk of generating AI slop by how I build. And so first pillar is be the architect. That means that you need to make all the decisions, not the agent. Secondly, use sparring partners. I used LLMs, but also humans. The third one, follow generally good engineering practices. And the fourth one, systematically evaluate your output. So let's dive in with be the architect. This means that you need to think things through up front. I had, like, a part of me just wanted to tell Replit, okay, I kind of want this app, go. And that's not a good idea. So instead, I was a good product manager, and I thought about user experience design. So like what user flows and what should the UI kind of look like on a high level by doing mockups. So I did all of that up front. Secondly, I spent time to think about the system architecture. So how will the different components interact with each other? How will it be structured? Which services will talk to each other? What technology will I use? So what's the core tech stack? What data storage and schema should I use? What are the key services and integrations that I will choose? And I thought about this for a long time, and I made a lot of mistakes here. The good thing is that you do not need to do this alone. I talked to Claude a lot about this. And Claude is also quite good at spinning up a really nice technical specification that you can give to Replit. You can also tell Claude to do it step by step as to not to overwhelm Replit. So I thought about all this stuff up front. Nonetheless, I made mistakes. I'll get to that later. And very important to understand AI agents will pick really weird paths, will make very strange choices. Why? Well, because they're AI. And secondly, they just don't know about the latest libraries and tools. For example, I had this thing, I upload PDFs and it needs to turn that into JSON or Markdown or some format that Claude, an LLM, can work with later. And at first it wanted to take pictures of every page with OCR and do some really weird conversion. I used Replit plan mode a lot to understand what it's planning to do, and then fed that into Claude or just looked at it with my bare eyes and figured, no, that's a terrible idea. It also, whenever I identified a bug and explained it, it wanted to have this huge blacklist of things that the LLM should not do all put into the prompt. So basically the AI, if you let him do his thing, he does really ridiculous stuff. So I mentioned I made some expensive mistakes. It cost me a lot of time. I totally fucked up the database. I first went with SQLite following Replit, which makes no sense because every time you redeploy SQLite, all of your users disappear. So I had to migrate that to PostgreSQL. I used the wrong parsing service. So first I used Llama Parse, which turned out to be really bad at stylized text and tabular content, which actually technical manuals have a lot of, so I had to migrate that. And also which LLM I actually used for the augmentation, for giving an answer to the question. I first had GPT-5, I played with the temperature settings, still didn't like the output, then added Claude 4.5, had both of them so I could compare the output in my product, and then in the end I moved to only Claude 4.5. So that was a lot of back and forth. This is also why it was expensive, but also why I learned so much. Second important one, use sparring partners. So Replit has a plan mode. I used it a lot. And I would feed the ideas that Replit had into Claude and ask Claude to critique it, and then put that back into Replit plan mode and go back and forth quite a lot. This works super well for me. Also really useful to help you get out of debugging holes. Sometimes when you run into a bug and you ask Replit to fix, you get stuck in this endless loop of Replit going, I fixed the bug. And then you check, and of course he didn't, like never ever. Whenever Replit is very enthusiastic about the fact that he fixed it, he usually didn't. But then like asking him to do to think about it a bit longer and maybe outline what he thinks is going wrong and what he's planning to do, and then copy pasting that into Claude for a critique. Very helpful. And last but not least, at the end, when I figured my MVP was done, ready for launch, soft launch, I asked my good friend Pepe Siletti, I will show you a picture of him later, a human that I trust, for a quick sanity check. So I gave him access to all the files and I said, can you just have a short look at this to see if it doesn't look terrible? So sparring partners. Third, important, follow good engineering practices. So there's a couple of ones that I use a lot. Like firstly, I kept telling the agent, do not hard code API keys. Replit has an inbuilt secrets tool, but I also explicitly told it to use it. Secondly, logging. I asked the agent to add meaningful logging to whatever I needed to debug later, or whatever I needed to debug at that moment, and then of course removing that logging after. Security, very important. So Replit has an inbuilt security feature. I can show you where it is. So this is my Replit. This is my thing. It has here on top all of these tools. So it has a security scanner. I ran this scan, it then gives an output, and you can feed that back into the agent. So here's agent 3. So I use that quite a lot, but I also just used prompts by going, hey, look at the entire code base and check if there are any potential security issues. For me, my biggest security risk is the fact that I don't want data from one user to be visible to another user, multi-tenant hosting. So I asked it to look at that specifically. And then also very important, I think, is regular refactoring. So I did this after every big feature. I just prompted the Replit agent, go back, clean up. And also just regularly, I had these checkpoints of saying, okay, now go through the entire code base, remove all debugging print statements, identify and remove any dead or unused code. Or actually, I said identify, not remove yet, but first identify any dead or unused code, explaining its former purpose and current replacement, and then afterward propose a plan to generally improve code maintainability and robustness. So I had it make a plan, then Replit gives you a task list, then you decide which one you wanted to do, and I would just have it go through it one by one. And in between every step, I would test whether the application still works, because you might have removed something that you shouldn't have removed. So I can only check that by having like a step-by-step plan and executing also step-by-step. But this helped me a lot. I think that regular refactoring was really important. Then the evaluations. So there's one thing about, how do I systematically evaluate the output? And this is something I'm bullish on. I've been talking to a lot of AI builders or tinkerers like myself, and I'm always shocked by how little people are doing to systematically evaluate the output. And I made this little horrible matrix, sorry that it's ugly, to show you the different levels. On level 0, we have the ad hoc vibe check, where you're just building, and every once in a while you just check whether it works, and that's it. Right? So what you do is you can find the most obvious bugs. But of course, it's super biased and definitely not systematic. And I found that many AI tinkerers are just doing that. I don't think that's enough. Then on level 1, there's manual review and triage. So here you systematically review real user interactions. So basically, I did that. So I vibe coded an annotation tool. And I did that within the same app. So in the Vera TechAssist app, I, Else van den Berg, am the admin. And for the admin view, it has more menu items than regular users. So I have traces, and I have a user overview, and I have feedback of the users. So I have this tracers menu item where I can literally see full transcripts and all kinds of technical data about what happened in that query, and I can review them. It was very easy for me to vibe code that annotation tool. It took me like 2 hours. And it was easy for me because I had been doing a lot of vibe checks, ad hoc vibe checks, because from those vibe checks, I understood the most common failure modes that my product was running into, so I could build those into the tool. I can show you quickly what that looks like. Let me get in. Okay, so this is my admin user. Regular users only see chats and documents, but I'm the admin user, so I also see traces, users, and feedback. So let's go into traces. So this one that I did. So here, I just vibe coded this, right? So it has the user information, performance metrics, the documents that were used, and the entire conversation. So this one's kind of non-exciting because I didn't actually do the full chat. Then there's a review status, and here are these failure modes. And they are categorized by, was it an issue about document retrieval? Was it about answer quality? Was it about images? Was it about other or custom? Because these are the things that I found that went wrong quite a lot. I can add some notes, I can set a tag, and then I can save it. So I just built this into the product. Of course, that's a bit risky, right? Because now we have an admin user that sees stuff that other users should not see, which is why I spend so much time on security issues and making sure that information from one user does not bleed into the other user. Then I also have a golden set. And so basically, it's kind of like a smoke test, I think. So before I redeploy, there is a golden set of 10 prompts that I always run to kind of check the output to see if nothing is totally broken. And of course, then last but not least, on the 3rd level, we have online automated evals. Here we have like hard-coded checks or metrics or LLM as a judge. These are these more advanced things that you should have for a proper production AI product. Because Vera TechAssist is kind of like a spaghetti against the wall MVP with maybe a few users, but it's not going to be a production grade app in that sense that it needs to be that great. I just went with this. So it has 1, 0, 1, and a little bit of 2. Last but not least, I think very important is to manage user expectations through communication. So on top, you see a little snippet of the cold outreach message that I'm sending. Firstly, I did not do like a full alpha launch for this product, right? It's not on Product Hunt. There's no Facebook ads. It's not like, wow, this is an alpha product. This is amazing. You should pay for this. This is it. I am just using it for cold outreach, where I say clearly, I'm building this tool. It's completely free. There's no strings attached. What is in it for me? Hopefully your feedback. I communicate also later on that this is a test product. It's a beta. And I repeat the word beta all over my homepage as well. So I try to communicate quite clearly that I've built this, that I'm giving this away as a test, and that it's not a fully fledged product. I also mention in the message that in the full product, in the end, I will speed up the responses. So there's a few rough edges. So I think transparency is just really important. Now, the answer to my research question, how bad was the code? So I mentioned I have a good friend named Pepe Siletti. He's been an engineer since 10 years. He's also a freelance product engineer looking for work at the moment, so grab this guy. He's an all-around great human. And he was kind enough to have a look at my code at the end, right before I launched, to tell me if there's anything insane. And here's his full feedback. He said, architecture-wise, pretty simple. A monolith. It says the project structure is good for the front end part, not so much for the back end. It uses a classic separation of behaviors into services. Okay for a small app, but for bigger apps, it gets messy pretty quickly. They just put all the files together. That is an issue if you consider humans working on it, but less of an issue considering that AI is working on it, which is actually the case. So, verdict, not perfect, but not slop either. Yeah, I hope this helps. I would recommend you to just do it. I do not think it is a distraction because I learned just loads about what it means to build an AI native product from scratch. I learned a lot about the technical trade-offs that you need to make, about the services that you can call, how to make these decisions. I learned loads about evaluation, which is just extremely valuable. And if you set it up correctly, like a proper test, I do think that delivery feeds into discovery. Good luck.